Imagine this. It's 9:45. You just got to UTD campus. You have a class at 10 a.m. What you need to do is find parking, grab your bag, and run to class. Where are you going to find this parking spot? Our idea is Spot My Spot. We're Team GrabW, and our solution is to use computer vision to find a parking spot and have this so you can look on your phone and find where the parking spot is. My name is Jason Wei. I'm the project leader.
I'm Tushar Rahi. I'm the project manager.
I'm Tommy, and I work with the hardware.
I'm Shabam Gore. I'm the tech lead.
And I'm Dustin Bagania. I'm the software lead.
So there's about 260 million registered vehicles in the United States right now. With this huge number, parking is becoming a bigger and bigger problem in the United States. Our main idea was that we want to create a working proof of concept to show the ability of our platform, which uses computer vision to determine whether a parking spot is filled or not. When it determines whether this parking spot is filled or not, then it will send this data to a server, and you can actually look at it on your phone, on a mobile website. So this allows you to easily find parking when you have 15 minutes to try and find a parking spot and go to class. So for this, we were able to create a prototype that actually will look at a parking lot and determine which spots are available and which spots are filled, and I'll upload all this data to a website, and then you can view it on your phone. So Shubham will be talking a little bit more about the performance metrics and how we went about doing this.
So basically, we had to, how do you grade yourself? How do you determine your accuracy? So nothing's ever 100% accurate. So we aim for 70%, and on all of our testing, we've way surpassed 70% accuracy. We've been able to determine within our tested simulation, if you put a car in a parking spot, you'll be able to tell if that parking spot is occupied or empty. And the second performance metric we have is this needs to run for like normal day hours when you care about whether or not there's parking. 7 a.m. to 9 p.m. pretty much accurate. If you're in the middle of the night, you probably will find parking anyways. I don't know what you're doing, but you'll probably find it there anyways. So basically how we have it is we have a camera connected to a Raspberry Pi that takes the overhead picture of the parking lot, and then from there we send it to our computer that processes the image, so it detects whether the spots are empty or full, and then it sends that data to our server, and then from the server, as it updates and pulls every 20 seconds, you just check on your website, and then 20 seconds, if you want an updated picture, just check it again and see if something has changed. Maybe a spot opened up in the parking lot you were right next to. Maybe it didn't. We never know.
And to go more in depth about the software and hardware components that we used in order to create this, we have Tushar and Dustin.
So I worked on making the website side. So initially I thought we should use the LAMP stack because it was open source. So it was Linux, Apache, MySQL, PHP to create the website. But then we later transitioned into React and Node.js to communicate with Amazon AWS. The reason we did that was because for AWS we needed a React build file or a folder to run it, to host it on AWS. So we went with that. And our output from the camera goes into a JSON file. And from that JSON file, we parse it to give the values to display on the website. And Dustin will talk more about AWS.
So like Tushar said, we use AWS. We implemented an S3 bucket to hold our data, which will also contain the website. We did look into an RDS, and for now we were looking at one parking spot, but if we were to broaden this up to many parking spots, we would use that RDS database to basically hold our data in. And then as for the camera processing, we uploaded OpenCV and Candy edge detection on our Raspberry Pi. And so what would happen is the Pi would take the picture, process it, and then send it to our database, or AWS, to basically upload it to our website. And then Tommy will talk about more of our hardware side.
So our idea, we wanted...
4 minutes.
Go ahead, keep going.
Questions?
Yeah.
It seems to me that accuracy is pretty low, for 70%. Why is that? How can you improve on that?
So that was actually our performance metric as a baseline, but we've actually been hitting upwards of 95%, 97% on the accuracy. So it's pretty accurate. That was just our performance metric as a way to show that the system works. Yes.
It seems like you guys are about most of the way, but not quite there, because, you know, the last thing you want is somebody driving through the parking lot looking at a website on their phone. Have you taken it that last step to get some kind of an oral alert, either Siri or, hey, there's one, you know, somehow where it says, look, there's one 20 feet up ahead, or there's one in this parking lot, something where you don't have to look at your phone, where it'll give you some kind of a voice signal?
Yeah, so we looked into that a little,
Okay.
but it was like that step is almost like a whole new project,
Okay.
trying to integrate voice and
Okay.
trying to say, like, read it out to you and things of that nature. Like, you need to like work with a lot of different packages that like would extend our project even to like another year or
Okay.
even like half a year.
Okay.
So it's timing more.
Okay.
Is this
Sure.
system right now just off of one camera, or have you looked at, looking at a full parking lot, many cameras, looking at the data together and saying, this is how I can look at the entire parking lot?
So actually, Tushar can talk more about that. We worked with one camera on the demo that we have downstairs, but he can talk about the
Yeah,
multiple
so we'd
cameras.
have to use more on the AWS side for that, since it would be, because AWS, one of the features is load balancing. So like if we were to expand to like an even bigger parking lot, we'd have to like balance how much the load AWS is taking from the multiple cameras being, like the multiple processes from like each image.
All right, last question?
So, what weather conditions do you test it in? Clear sunny day, or do you try stuff like rain, fog?
So we did it, it's actually a demo downstairs, so we actually did it indoors for the testing. We had identification, so it can find whether there's something in the spot, so whether it be a motorcycle, a car, or just any object in the spot. We didn't kind of, we would need to like grow our model and make the identification better in order to accommodate other weather conditions. But we definitely think that was like a stretch goal, like to be able to detect in, low lighting, fogginess, rain, snow. But that's not something that we finished in the scope of our design project.
All right, let's thank the team.